I made a video yesterday or the day before, I think, and I was talking about hand-eye coordination. What I was thinking about in that video was to do with, well, it was to do with the kind of cognitive mechanism that lies between the hand and the eye, and that kind of, well, it just allows for that kind of coordination to take place. And what I was trying to reach towards with that video is to talk about a number of things. Well, firstly, that whatever that system is, that cognitive system, it's a sensorimotor system. It reaches forward into the senses, like the eye, the sensory organ of the eye, but it also reaches forward into the motor actions of the hand and any other motor actions. And also there's not a clear dividing line between sensory and motor actions in that anyway, because the eye, in order to act as a sensory organ, has to carry out all kinds of motor activities, things like contracting it and dilating the pupil, saccading the eyeball backwards and forwards, all those kind of processes, and doing the muscular thing with the lens to allow it to focus. So it's deeply motoric, I think is the word anyway. So that process is a sensory motor process. It also, I think, involves what might be called representations, action representations, which we've talked about elsewhere, in which the kind of, well, for example, seeing a ball and coordinating your hand to catch it, that kind of hand-eye coordination. The ball is represented, and part of that representation is, well, actually all of that representation must be sensory motor. It's not a picture of the ball you're seeing, it's a picture of the sensory motor actions that you're involved with in perceiving the ball and responding to it. And that, I would guess, would largely take place in those smaller motor actions, like the muscular effort involved in focusing, pupil dilation, saccading of the eyes, and all of the other activity that needs to be subtracted from that in order to create a stable image. So all that kind of stuff, I think, is in place. It's to do with the sensory motor mechanisms coordinating hand and eye, forming representations of the world. Okay, but the other thing about that, which I was interested in, is that whatever that process is, however that mechanism works, it can't be a simple, singular mechanism. I don't think it's just a question of like pouring the sensory information at the top and having the motor information come out of the bottom. Whatever's happening in the middle must be, well, of course, complex, but it must be modular in some way. I would imagine that, if I can use a computer analogy a little bit, there must be all kinds of subroutines going on in that process. So the action of, for example, just the action of seeing the ball in flight, which, as I say, is partly a sensory, partly a motor activity, and there's no clear division between those. Just the action of seeing the ball in flight would require a number of very different activities to be collated. I would have to say something like subroutines. So, for example, there must be, let me have a think. Well, there must be a subroutine that compiles information. So if there's some part of your sensory motor mechanism that's recognizing, that's doing the kind of figure ground thing and identifying some kind of figure against the background of the sky, the figure of a ball against the background of the sky. And there's another part of your process which is doing some kind of color recognition. And then there's another part of your process which is recognizing edges. And there's another part of your process which is recognizing motion. And that's all taking place in this sensory motor representational system. Then there must be a subroutine which brings all that together and gives us the single unified experience of a ball of a certain color with clearly defined edges against the background of the sky in flight or in motion. Because we don't see it as a whole catalogue of these different features, we see it as a single unified experience. So there must be a subroutine that unifies all those experiences. And there's probably others as well. I'm sure there are other routines, like there must be a routine which separates things out, because if the ball passes in front of a tree on its way towards me, it doesn't suddenly become part of the tree. whatever that unification process that's going on, that pulls that binding process, I suppose, that collates all that stuff into a single experience, which I call an object in flight. It is distinguishing it from the tree as it passes by it. So there must, for example, in that case, be another subroutine that's forming distinctions and that separates things out. And in fact, the very fact that I can see a tree and not see it simply as a singular thing, but can see it breaking down into branches and leaves and so on. And there's a kind of constant figure ground shifting in that kind of perception. Again, means there must be a subroutine in the sensorimotor representation that I'm having of that tree, which is constantly reducing it and breaking it. And I'm sure there are others. So there's at least two there. There's one that binds and one that breaks up, and probably a whole bunch of others. What I was thinking about in terms of, well, just reminding myself really what I was talking about the other day when I was talking about hand-eye coordination, is I think I closed that video by saying that any kind of decent engineer worth his salt, having constructed some kind of a mechanism as complex as that sensorimotor representational system between hand and eye, wouldn't just let it serve that one purpose of allowing it to catch balls in flight. It would multi-purpose that, because that's an immensely complex system, and it could be put to all sorts of different uses. And I would imagine that the things that would be put to different uses would be things like subroutines. Now, I'm just speculating here, but if it did come about that somewhere in evolutionary history this fantastic sensorimotor cognitive mechanism evolved, which allowed some weird creature which just had one hand and one eye, if it evolved to catch balls, that's what it did, and that's how it survived, then just the existence of the subroutines in that system, which allowed it to perform that one action, would inevitably allow it to perform other actions which involve those subroutines, like binding. Like if this creature suddenly grew ears, for example, it would allow me to do what I'm doing now, which is to put the sounds that I'm hearing against the images that I'm seeing. So I'm seeing cars on the bypass right now, and I'm hearing cars. But I don't hear them. That's not two separate things I'm doing. I'm seeing and hearing the cars on the bypass in a singular way. So this hypothetical creature with just a hand and an eye that grows an ear, I would imagine would be able to find a use for those subroutines in order to bind that, what becomes an aural experience, and also to fragment those aural experiences if it wished. And the same, I imagine, would be true of any other senses that happen to grow, and any other subroutines that happen to find itself in possession of. Oh, but